Alright, it is 1.7 solutions in concentration. So we'll go through calculating concentration of solution and titration. Yeah! Alright, so the first thing is to define what concentration is. And in Cambridge curriculum, they define concentration as moles per volume, and the volume is decimeter cubed. And yes, it is different as what normally you define concentration as molarity. But decimeter cubed is the same thing as liter. Yes, damn British. Um, so whenever they see liters or decimeter cubed, it's the same thing, just like centimeter cubed and milliliters. So just a little bit of difference. Um, Basically, concentration is defined how many moles you have in a particular set of volume, generally 1 liter or 1 decimeter. Alright, get right into the example. We have 250 centimeter cubed solution, and it's 2 grams of sodium hydroxide. So to find the concentration, you must remember that it's moles per liter or moles per uh, decimeter cubed, or moles decimeter to the negative third. That just means it moves up to the numerator, not the denominator. Um, so we must get grams into what unit? If you're thinking moles, then you are correct. If you're not thinking moles, then you need to get on the mole train. So, how many moles? 2 grams is 0.050 moles of NaOH, defined by the, you just divide by the molar mass. How many decimeter cubed? If you said 0.25, you are correct, because you just divide by 1,000. So to do concentration, it's moles per liter, or sorry, moles per decimeter cubed. So just divide the two, and you get 0.20 molar or molarity, big N. Alright, now it's asking to find the mass of anhydrous copper 2 sulfate. So we need mass. What given unit, centimeter cubed, moles, decimeter to negative third, and the problem that we can get us to mass. Well, the question is, what's our given? And the given is 55 centimeter cubed. The molarity is a conversion factor, just like density is. It's moles per liter, moles per decimeter cubed. So if it's a derived unit, it's used as a conversion factor. Don't forget to change the units. Divide by 1,000. Now we can use our molarity to get to moles. See, 0.20 moles per liter. And the last thing is to get to mass, so we need the molar mass of copper 2 sulfate, which is 159.262. Moles cancel, and we have 1.8 grams in the solution. Alright, here's your homework question. Calculate the concentration in moles per decimeter cubed of the following solutions. 1, or I, solution of NaOH containing 2 grams of NaOH in 50 centimeter cubed of solution, or 50 milliliters. And 2, a solution ethanoic acid, HC2H3O2, or acetic acid, or vinegar containing 12 0.0 grams of ethanoic acid in 250 centimeter cubed of solution. Alright, part B, titration. Used to determine the amount of substance present in a solution of unknown concentration. So basically, we're trying to figure out, you have an unknown solution and trying to figure out how many moles per liter or how many moles are in that solution. You can see here, remember titrations, we use a burette and you swirl, or you're not going to swirl with a stirring rod or stirring magnet, sorry. You go slow and you reach an endpoint, which is very faint pink. You go darker, it's too far. You gotta start over. Reading burettes, pretty simple. You always read the initial amount first, which is this actual middle row. And you titrate, you get to the final burette reading. And the reason why that's on top is because large minus small gives you the difference. Okay. So steps for titration is just like simple any other reaction. You must balance the equation. You gotta find the volume used. You need the concentration of the solution in the burette, the volume of the solution in the flask if known, and if known, the concentration of the flask. So all of those can be used in titration, or can be asked to find a concentration or titrations. Alright, so here's an example. We have NaOH and sulfuric acid, balanced equation, making Na2SO4 and H2O. The volume used in the burette is 15.15 centimeters cubed of our acid. The concentration of the burette is 0.2 moles per liter or moles per decimeter cubed. We know that the volume in the solution in the flask is 25 centimeters cubed of NaOH. What is the concentration in the flask? So, the first step is to find how many moles of our acid. Then we have to use the balance equation to find the moles of our base, and then take moles per liter, moles per decimeter cubed. Okay, so try to work out this problem. If you have any questions, we can go over this in class. Alright. Another example. You have 25 centimeters of strontium hydroxide. It was neutralized with 15 centimeter cubed of a 0.100 molar solution of HCl. Calculate the concentration of strontium hydroxide. So same steps involved. You gotta find the moles of HCl. Then use the balance equation to get the moles of strontium hydroxide. And then from there you can do moles per liter or moles per decimeter cubed. So you should get 0.0300 molar of strontium hydroxide. And again, we can go over the steps in class. Alright, here we have a 0.05 molar solution of a metal hydroxide. Not sure what it is, but it is titrated with a 0.2 molar solution of HCl, and it required 12.5 centimeters cubed of the HCl to neutralize the base. Find the stoichiometric ratio. So basically try to find the moles of each and do the ratio. So you can find the moles of your hydroxide using the concentration and your volume. Same thing for HCl. And you should come out to be, well, you get moles. 0.00125 moles of our metal base and 0.0025 moles of our acid. Do the ratio and it should come out to be 2 to 1. So 2 moles of acid to 1 mole of base. Alright, second homework question. Same type of problem. You're trying to find the stoichiometric ratio. You have 20 milliliters of the metal hydroxide of 0.060 moles per liter of your base, 0.100 moles per liter of your acid, and 24 milliliters of that acid. So the first step is to find the moles of our metal hydroxide. So you gotta get 20 milliliters into liters or decimeters cubed. Use the molarity, and that will give you moles. Same thing for your acid. Then take the ratio, and then from the ratio you can use write the balance equation. So whatever the ratio is, those are the coefficients for your balance equation. Okay. So let me know any questions. We can go over any problems in class. Okay, thanks. Oh, sorry. Those are your answers. So make sure you check it, but you gotta show your work.